Alright, so we are going to start our very first lab, which is lab 1. Now in this lab, we actually talk about numbers and we try to convert between different number systems. Now first of all, the number system that we use in our regular lives, we know it from like our elementary schools, are called decimal numbers. And we pretty much write all the numbers using this system, right? This is a number system. So in the decimal number system, we have 10 digit, right? 0 to 9. And we can pretty much write every number using this 10 digit. So that's why this is called a 10 base number system. But remember, that doesn't mean that this is the only number system on the world. There are plenty of other number systems. You can pretty much write any number using those number systems. So in this class at the beginning, we talk about the number system because digital circuit has a strong connection with a different number system than decimal. Now, as I said, as you know, that the decimal number system, whatever you are writing, every position has a weight, right? So if this is your decimal point, so every digit you write, the more you go to the left, the digit has more weights, right? Because every position has a weight. Let's say the very rightmost position has a weight of 10 to the power 0, which actually is 1. And then if you go to the left, it's 10 to the power 1, 10 squared. So every position has more weights than the previous ones if you go to the left. But if you go to your right, every position, even after the decimal point, every position has lower weight than the previous one, right? So for an example, the very first one after the decimal point has a weight of 10 to the power negative 1. That means 1 over 10, right? 10 to the power negative 1. And then 10 to the power negative 2, 1 over 10 squared. So I'm just trying to give you an idea of exactly what we have in our number system, okay? But we are mostly interested in about a different number system, which is called binary numbers system, okay? Now, all the digital circuit and the digital world has a very strong connection with this number system, okay? In this number system, unlike decimals, we actually have only 2 digits, which is 0 and 1. So it's actually interesting because you have only 2 digits, so you actually have to write every number using these 2 digits. You might be wondering, how can I write 27? Because there is no 2 here, there is no 7 here. You just have 2, 1 and 0. But yeah, there is a way you can write every number in the binary as well, which is an equivalent of decimal, okay? So today we'll learn how to do this. There are some easy techniques, so we'll follow some easy techniques. So again, as I said, this is, binary is a number system, you have 2 digits, so this is a 2 base number system. So that's why, as you have seen in our decimal numbers, all the weights were given in terms of 10, right? Remember, 10 to the power 0, 10 to the power 1, 10 squared. Now here, since this is a 2 base number system, all the weights are given in terms of 2. So every position has a weight, like 2 to the power 0, 2 to the power 1, 2 squared, 2 cubed, 2 to the power 4, 2 to the power 5, okay? So, and similar, after the decimal point, every number has a negative weight, okay? Now, before we start looking at how we can find out the equivalence, I tried to give you a list of numbers that you can see here. You probably will not understand how we wrote those, but I'm just trying to show you that there is an interesting sequence here. So if you look at here, see, this is our decimal numbers, right? We just have written from 0 to 15 here. But at the right side, those are the binary equivalent of these decimal numbers. So basically, if you write 4 zeros, or like 0, 0, 0, 0, that's like a binary, I'm saying decimal, that's like 0, this is 1. Look at the 2. 0, 0, 1, 0 in binary is equivalent to 2. 0, 0, 1, 1 is 3. 0, 1, 0, 0 is 4. So we actually don't know how to write it yet, right? But there is an interesting pattern that I wanted to show you here before I start the conversion technique. Look at the interesting technique. If you go to the very right column, you see that 0 and 1 is flipping in every number. You see here, 0, 1, 0, 1, 0, 1. So it's actually like flipping. If you go to the next column, 0 and 1s are flipping in every other column. So it's actually like 0, 0, 1, 1, 0, 0, 1, 1. See it? And then if you go to the next column, you see there is also a pattern. There are 4 zeros and then 4 1s, 4 zeros, 4 1s. If you go to the very leftmost one, you have first 8 number are zeros, and then there is another 8 number which is starting with 1. I'm saying even if you see this pattern, you may not see it before. Right now you see the patterns. We probably will not be using the pattern to write the number, but I'm just showing you that how you can see that there is also a pattern. I'm saying it's not like, oh, we just randomly wrote like zeros and ones. Okay. Now, so the first thing that we'll try here today is how to write a decimal number from a given binary. So let's say you are given a number which is a binary number. Okay. How do you know what is it in decimal? Okay, so let's say you are given this number. I just took it as an example. This is 100101. Okay. Now this is how actually I write it. So we first will write all the weights. Now how did I write these weights? Let's recall. Remember, all the weights comes in terms of 2. So the weights are like this: 2 to the power 0, 2 to the power 1. 2 square, 2 cube, 2 to the power 4. It actually goes on like this, okay? The more you go to the left, 2 to the power 6, so you know exactly how, So, but I actually wrote the weights here because 2 to the power 0 means what? 1, right? 2 to the power 1 is what? 2. 2 to the power 2 square is what? 4. 2 cube, 8. 2 to the power 4, 16. 2 to the power 5, 32, 2 to the power 6 is 64, right? This is exactly what actually I wrote. So you see here, I actually wrote 1, 2, 4, 8, 16, 32. Okay? Those are the weights. I actually got the weights from here. Now, there is another way you can remember this weight. You actually don't have to remember, oh, 2 to the power 0, 2 to the power 1, you don't have to remember all of it. All you need to know is this. Look at this. All these weights get doubled every time. So the first one is 1, and then if you multiply it by 2, it becomes 2. If you again multiply it by 2, it becomes 4. Multiplied by 2, it becomes 8. Multiplied by 2, it becomes 16, 32, 6. So every time it actually gets double, which is very easy to remember. You start from 1 and then keep it, make it double every time. Okay? So that's exactly the same thing. Now, so you first write all the weights. So we have a binary number here, right? Look at our binary number. This is 100101. So we actually have to find out what is the equivalent decimal, right, of this binary. This is how we actually do it. Look at what we exactly did. We actually wrote all the weights at the top, and then at the bottom we wrote all the binary digit of that number, right? The number that is given to you. And then what you do is we only take the weight of the column where we have 1. So you see here, we have 1 here, right? So we took this 1. We have 1 here again. So every column we have 1 at the number. See, we have 1 here at the number, so we took this 4 at the bottom. We have 1 here, right, at the very left side with the 32. We took that weight at the bottom. So we actually added the weights. We are only adding the weights where we have 1 at the number. How much you get if you add these? 32 plus 4 plus 1. 37. So that means the given binary number is equivalent to 37 in decimal. That's what I'm saying? It's actually very easy. All you have to do is just write the weights. You know how to write the weight, right? You start from 1, get it double every time, and then write the digit at the bottom. So, and then only add the weights where you have 1 in the number. Okay? Now, if you understand up to this point, you are actually ready for the very first part of the lab 1. Let's go to the quiz section in pause. Let's try our very first lab, is actually the part 1A of the lab, which is called lab 1A. Go there and try lab 1A. There will be a couple of questions there, and each of the question you'll be given a binary number. You have to follow this procedure to convert it to the decimal and write the decimal in the box. Once you finish it, submit it, you will see the grade. If you don't get 100%, again, you can try it later, okay? Just try it for once now, and I'll give you a pause here so that meanwhile we can try, okay? So we'll try our binary to decimal method here in lab part. So you just need to try the first 5 questions of the lab part 1A. Okay, once you finish those 5, we'll talk about something else so that you can finish the remaining 5 of the lab 1A. So hope you are done with those 5 questions, right? Let's try our next method, which is the reverse one, like decimal to binary. That means if you are given a decimal number, how can you find the binary number? Okay, we actually have 2 methods for this one. So we'll actually try the easy one, but we also want to understand the other one because it will be helpful for the next steps. So this is how we actually use our first method. Now let's say we are given a decimal number which is 49. Okay, then we have to find out how do you write the binary 49 in binary. Okay, now what I did is at the very beginning I wrote all the binary all the weights. We know the weights, right? Excuse me. So you can write 1, 2, 4, 8, 16, 32, all the weights. Okay, now to write 49, can you tell from the weights? You have the list of all the weights, right? Can you tell what weights you have to pick to make it 49? That means which weight you need to add to make it 49. Now interesting thing is there is only one combination of the weight you need to pick to make it 49. So that means what I'm saying is pick some weights from this list which will add to 49. Let me show you. If you pick 32, if you pick 16, and if you pick 1, that's 49, right? Now the interesting thing is there is no other way you can pick a different combination of the weight to make 49. This is the only single combination you have. So that means for every decimal number you will have only one single combination. So if you try and see, there is no way you can make 49 except you take 32, 16 and 1. Now once you know that combination, it's actually very easy because all I have to do is I have to put a 1 under that weight. Under every other weight I put zeros. You know what I'm saying? So look at this. Now I put a 1 here because I picked this weight, right? I picked this weight, so I put a 1 here. I did not pick the other weights. I put all those zeros. So regarding 64, you actually even don't have to write it because that's like a 0 at the beginning, so it doesn't make any difference. Okay? So, and then your answer should be 110001, right? You don't have to write the first 0. If you want, you can, but that's optional. Okay? So your answer is 110001. That's the binary number which is equivalent to 49. That's what I'm saying. Now let's go to pause and let's complete this lab 1A. So we have the remaining 5 questions based on these. So you'll be given, in every question you'll be given a decimal number. So just follow this method to do the binary. So again, if you need some more examples, you can always go to the tutorial section. You know, there is a pause, there is a tutorial section. There are plenty of links there. If you go there, there is a lab 1 example link. If you open it, let me show you here if I can. So for an example, if you go to pause and go to the tutorial section from your left side and then click this one, lab 1 examples, it will actually open up a handwritten file where you have some more examples for all these in case if you want. Okay, but we have examples in the slide as well. So I'll keep it here. I'll give a pause so that you can try the remaining questions we have in lab 1A. Once you finish it, you can submit it. If you don't see you have 100%, again, as I said, you can try it again. Okay, not right now, but when you get home, try it again, make it 100%. Okay, you can try it again and again. Every time you might not see the same exact question, but pretty much the very similar question. Let me give a pause here so that you can try and complete your lab 1A. Okay, there is a second method of doing it. I know that most of you probably already tried this method, but I still want to give you a touch of second method because that second method is really useful in future when you do some other techniques. So let me show you how the second method works. The first method is fine, there is no problem with that. So in the second method, we still do the same thing, going from decimal to binary. So this is how we do it. I actually picked the same number just to show you that how it works because I'm still picking 49, the same number, okay? Now this is how I actually do it. This method is called reverse division, okay? This is how I do it. Let me show you. So if you look at on the projection so that we can see exactly how we are working on it. So we first write 49 and then 2 at your right. So what we are going to do is we'll keep dividing the number by 2. So but this time here we divide the number just like a third grader, okay? So we do not get any fraction. This is how we divide it. So for an example, for dividing by 49, this is how we divide. So if you divide 49 by 2, how you divide? 2 times 2 and then you just write what? 2 times 2, 48, right? And then, so you get this, right? 2 times 2, 4, and then 2 times 4 is 8, then you subtract it, you get 1 as the remainder. So this is called, you have a remainder of 1 and you have a quotient of 24, right? Remember when you were in third grade, you never got the fraction, right? So you just kept the quotient and you kept the remainder. So you'll exactly do like this. The problem is your calculator will not give you that way, right? The calculator always gives you the fraction. So what you do is you just divide 49 by 2. Your quotient is 24, so you write quotient. So this is your decimal number, this is your base, and then you keep your quotient here, you write your remainder at the top. So every time you divide, you write your quotient at the bottom, at your left, and you write the remainder at the top. We are not done yet. We'll keep dividing, okay? So our next number is 24 to divide. When you divide 24 by 2, what do you get? 12, right? What is the remainder? 0, right? Because there is no remainder. But remember, there is no remainder means the remainder is 0. So you actually have to write it. So this is how I write it. Look at this. I write 12 here, remainder is here. So I always write my quotient at the bottom at my left, and I write the remainder at the top, again at the left. Okay? I keep doing the same thing. So now I'll be dividing what? 12, right? By 2. What will be my answer? What will be my quotient? 6, right? And what will be my remainder? 0, right? Because if you divide 12 by 2, you get no remainder means 0 because you still have to write 0, okay? So I wrote 0 there, okay? I'll divide 6 again. So I'll actually keep dividing it unless I reach to 0. So now I'm dividing 6 again. What I get? 3, right? What is my remainder? 0. So, no, remainder is 0, right? 3 is the quotient. 3 is quotient. Quotient is actually the answer of the division. That is called quotient. And this is my remainder, right? Now, you divide 3 again because you do not stop until you get 0. So I divide 3 again. What I get if I divide 3 by 2? What is my quotient and what is my remainder? Quotient is 1, remainder is 1, right? So this is my quotient and this is my remainder. This time the remainder is 1. I do not stop here. I'll keep dividing. So I'll try to divide 1 by 2. What happens if you divide 1 by 2? You do not get any fraction, right? You cannot get any fraction. What do you get if you divide 1 by 2? This is what you get. You actually cannot divide it, right? Because you cannot get a fraction. So basically what happens is if you try to divide 1 by 2, the whole thing will become a remainder because there is no way you can divide it, right? So basically the 1 becomes your remainder and your quotient becomes 0 because you could not divide, right? quotient is 0, remainder is, so basically you stop until the last quotient is 0. I'm saying you stop when the last quotient is 0. See, I keep dividing, right? And now I will stop because my quotient is 0 here. I stopped here. Now what is my answer? This is actually my answer, the yellow number. This is exactly the same number you got when you had 49 and you picked those weights. Now you might be wondering why I should do this, because the method 1 is so easy than this one. This might be a little bit different than, I'm saying quite different than the other one, right? This is actually a very powerful method, because if you have a really big number to convert, it's hard to find the weights. For an example, we actually tried only what, 49, so it was very easy for us to find the weights. How about if your number is 49,028? It will be really hard for you to write all the weights and find the weights which will add to 49,028, right? Then this is the best method. There are other way. There is another reason why I used it, because I'll be using a pretty much a similar method when we'll be doing some other conversions in our next class. Okay, this is a very important method. So again, as you know, I just wanted to show you that there is another way, and this is probably the standard way. The first method is like a little bit tricky one and easy one, which is actually good for small numbers. Most of the ones that we do in pause are the small ones, not too big, so that one still works. But this is the pretty standard method of converting any decimal to binary. Okay. Any question for this method? This is actually the end of lab 1A. Okay. We already, I think, completed all those 10 questions, right? So if you did, you can submit all those. And then if you do not get 100%, you can try it again once you get home. So try it, make sure you get 100% before you return, okay? Let me stop for this one.